All right, hey everyone. So today we are going to be going over how to solve linear equations with variables on either one side or both sides. So first, we're going to have, we're going to do our first practice problem. So we have 2x plus 2 equals 8. So this might be a review for some of you or not, but what this x is it's a variable, and it represents a number we don't know yet the value of. We don't know what that x represents, but we're going to solve to find out. And we can define a variable as an expression with an unknown value that we can eventually hopefully find out. So first, let's try to solve the problem, all right? So we have 2x plus 2 equals 8. So the first step you want to do is make sure to isolate your variables. So we're going to put our x's on one side and our integers, or our whole numbers. Okay, so let me write this down real quick for you. Integers. An integer is a whole number. So 1, -1, 4, 6, -8, anything that's a whole number is an integer. So first off, we're going to isolate our variables, and how we can do that is we want to move all our integers to one side. So we have 2x plus 2 is equal to 8. So remember, one really useful thing you can do with equations is what's on one side has to equal whatever happens on the other side. So if we can get rid of this 2, right, we can subtract 2 from both sides. Subtract it from this side, and because of the equal sign, we have to do the same on the other side. So 2x plus 2 minus 2 is just going to be equal to 2x plus 0, which is 2x. And that equals to 8 minus 2, which is 6. Now that we have this, we can isolate our x further by dividing both sides by 2, right? To get rid of this 2x and make it into an x, to find out what x is. So divided by 2, we can get 2x divided by 2 is going to be x. And the same thing on the other side. Remember, because of the equal sign, you always got to do the same thing on the other side. So 6 divided by 2 is going to end up being 3. So x equals 3. So hopefully that makes sense to you guys. Next, let's go into this problem. 3x plus 4 is equal to x plus 12. So now we have actually variables on both sides. So it's going to be a multi-step problem where we have to isolate both our x's and our integers. So first, let's take care of our integers, right? So what do we do first? Do you guys remember? Take a second to maybe think about it. Okay, so if you haven't paused the video, what we can do is we can move all our x's to this side by subtracting one side's x values. So let's do it for this side first. So we can subtract x on this side to get rid of the x here, but remember we have to do the same on this side. So if we subtract x from 3x, we're going to get on this side 2x plus 4. And on this side, if we subtract x from x plus 12, we're just going to get 12. Now that we have this, let's use a different color, we're going to subtract our integers on the common side. So we're going to get 2x plus 4. If we subtract 4 from this side, we have to subtract 4 from the other side. And we're going to end up getting 2x plus 4 minus 4, which is just 2x, is equal to 12 minus 4, which is 8. Now, let's divide both sides by 2, right? To get rid of this 2 on the x. 2 is a coefficient. Quickly, to review what a coefficient is that is a number that is being multiplied by x, or a variable, by a variable. So it's the number attached to the variable, basically. So now we have 2x equals 8. How do we get rid of the coefficient on the x side? We can divide by 2. Always divide by the coefficient. And remember, you can only do this once you have all the x's on one side and all the integers on the other side. So once we get to this step, you divide both sides by 2, you end up getting 2x divided by 2 is x, which equals to 8 divided by 2, which is 4. There we go. Awesome. All right, now we're going to get into a little bit of a longer equation, but don't worry, this is hopefully not going to be too hard. So right here we have 3k minus 14k plus 25 is equal to 2 minus 6k minus 12. So we're not using x anymore, we're using k, but really it's the same concept. You can use any number or any letter you want to represent that variable. It could be x, y, z, or k in this case. And our first strategy here is on each side, we're going to combine the like terms. So what does this mean? Like terms are when expressions are both integers, whole numbers, or the same variables. So for example, 2 and 4 are like terms because you can combine them. If you can add them, you get 6. You subtract them, you'll get negative 2 or 2. X and 3x are also like terms because they're both multiples of x. If you combine them, you can get 4x, for example. 2 and x, however, are not like terms because if you combine them, you can't simplify that down. You'll just get 2 plus x. So back to this one. If we have 3k minus 14k plus 25 is equal to 2 minus 6k minus 12. So let's combine our like terms, right? I like to underline them. That usually helps me. So on this side, our like terms are 3k and 14k. 25 is kind of by itself. On this side, our integers, right, our like terms are 2 and negative 12. So let's simplify that down. If we do 3k minus 14k, that's going to end up being negative 11k. And we're going to leave that plus 25 alone for now. And then on this side, we have 2 minus 12, which is negative 10, minus 6k. We leave that negative 6k alone. And then now this is just like any of our other problems, where what we're going to do is we're going to isolate the variable, and isolate the integers. So let's do the variables first. If we have negative 11k on this side, how do we get rid of this negative 6k over here? Over here, how do we get rid of that? Well, we are going to add 6k to both sides. Add 6k to this side, add 6k to this side. So what that ends up being is negative 11k plus 6k plus 25 is going to be negative 5k plus 25 is equal to negative 10, right? Because we did negative 6k plus 6k, and we have the negative 10 remaining. Now let's isolate the integers on one side, right? So we have this plus 25 on this side. How about we bring it over on this side? What we can do now is subtract 25 from both sides, right? Because it'll get rid of it on this side. Subtract 25 on this side as well. So we end up getting negative 5k, what we have left over on this side, on the left side, is equal to negative 10 minus 25, which would be negative 35. If we divide both, remember now we have the coefficient, we want to divide by the coefficient, which is negative 5. If we divide by negative 5, and then we divide by negative 5 on this side, we get k is equal to 7. Negative 35 over negative 5. So there you guys go. K equals 7. All right. And let's try another one with a decimal really quick. So this one, we have 1.5x plus 3 equals 6. So again, we're going to isolate our variables. If we subtract 3 from each side, we get 1.5x is equal to 3. And now we divide by the coefficient, right, like we always do. Divide by 1.5. And you can use a calculator if you want for this one. If you divide 3 by 1.5, you actually end up getting that x is equal to 2. So really, it's the same process as decimals. Remember, you always want to combine like terms on each side first. Okay, I'm going to actually write this down real quick for you guys. So step 1, combine like terms on each side. Step 2, you're going to isolate the variables on one side. Step 3, isolate the integers on the other side, and then divide by the variable coefficient. Then you got your answer. Thanks for listening.